Hey, this is Mr. Aiden. This is the 2023 AP Calculus AB exam free response question number 3. This is from the newly released 2023 exam that was taken on May 8th. And I'm Mr. Aiden. And go to my website, go to my YouTube channel for all your calculus needs. So let's get to this problem. This is question number 3, the start of the non-calculator questions. And you can see it's a differential right away. You can see it's something about a bottle of milk. You can see M of t is measured in degrees Celsius. T is the number of minutes, and you can see M of 0 equals 5 degrees Celsius. That's a big thing that we want to make sure we understand, as well as your temperature is always going to be below 40 degrees. You can see they gave me a differential dm over dt. And so it starts right away with a slope field, and we want to sketch a solution curve through 0, 5. And there's your M of 0 equaling 5 degrees Celsius. So at time 0, the milk is at 5 degrees Celsius, and you can see we're going to sketch our solution curve, which is going to asymptote right around at that 40 area there. And so we are going to then use that line tangent at t equals 0. So you can see we're using a tangent line. We're going to take a tangent line right here at 5 to try to approximate time equals 2. And so you can see we are first going to have to try to find that we know M of 0 is equal to 5 degrees Celsius. That's something we know. We're going to have to take dm over dt to find the rate or the slope of my tangent line. So 1/4 40 minus 5 will give you 35 over 4 degrees Celsius. So that's my slope, degrees Celsius per minute. And we're going to find the approximation at M of 2, which means we want to take M of 0 plus M prime of 0 times your change in your temperature. We know what M of 0 is. It's 5 degrees Celsius. We know what M prime of 0 is. That's 35 over 4 degrees Celsius per minute. And we're approximating at 2, which is 2 minutes of a difference there. And so we'd have 35 over 4 times 2. That's really 35 over 2. 35 over 2 is 17.5. You add that to 5, and we end up getting an approximation of 22.5 degrees Celsius. And that is a good approximation using your tangent line. Well, then it says write an expression for d squared m over dt squared, the second derivative. Well, I always like to, when I do these problems with differentials, I like to distribute this 1/4. So I get 10 minus 1/4 of m, and I'm going to take that second derivative. What's the derivative of 10? That's 0. What's the derivative of negative 1/4 m? Is negative 1/4 of dm over dt. And so I have to come up to my differential, plug it back in. Negative 1/4 times that is negative 1/16 of 40 minus m. And I hope you can see your m is always going to be below 40 degrees Celsius, which means you can see your second derivative, your d squared m over dt squared, is always going to be less than 0, which means it's going to be concave down. And if we take a look at what my graph looked like, yes, my graph was concave down. Well, what do we know about a approximation line at concave down? You remember, I drew it. We were taking that tangent line, which means our value is going to be an overestimate, isn't it? An overestimate. And because my graph is concave down, we're taking our tangent line, we're approximating our tangent line of that concave down, which is always going to be an overestimate. Then the great problem of separating the variables. We're going to try to separate our variables, and we're going to find a particular solution. Okay, this is one of my favorite things to do. So the first thing we get a point for is separating my variables. 40 minus m of dm equals 1/4 of dt. And you can see I separated my variables. That's going to be worth 1 point. You're going to do an integral sign for each, and you're going to take an integral. So that's 1 over 40 minus m. 1 over 40 minus m. What's the derivative of 1 over anything? Is natural log of 40 minus m. And since that m is negative, you've got to put a negative in front for the chain rule there. What's the derivative of 1/4 dt? Is 1/4 of time plus c. And so that is, again, worth probably a point for each side. 1 point for doing your integral on one side, 1 point for doing your integral on the other side. Now we're going to plug in our value of m of 0. So at 0 time, so 1/4 of 0 time plus c, that gives us natural log of 35. So you know c is equal to negative natural log of 35. That probably gives you another point for finding the c. Now we plug that back into this equation right here, and we're going to get negative natural log of 40 minus m equals 1/4 t minus natural log of 35. Okay, and now it's just going to be a bunch of algebra from this point on. I'm going to move over my negative. Natural log of 40 minus m equals negative 1/4 t plus natural log of 35. I'm going to do the algebra of natural log, which is e to the. So we have 40 minus m equals e to the negative 1/4 t, and that brings my 35 as a constant out front. So that's equal to 35, e to the negative 1/4 t. Now I'm going to move over the m, move over this. So m is equal to 40 minus 35, e to the negative 1/4 t. And that is my particular solution for this equation. And you always want to double check. Put in 0 for time. 0 for time, e to the 0 power is 1. 1 times 35 is 35. 40 minus 35 is 5. That satisfies my solution, and that is your particular solution. That is the 2023 AP Calculus AB exam free response question number 3. I'll be bringing number 4 really quickly. Thanks, guys. Bye.